Hello and welcome to this tutorial. In this tutorial, we're going to be looking at solving inequality using sign charts. In the last tutorial, we looked at different types of numbers, the whole numbers, the natural counting numbers, integers, the decimals, and different types of numbers that we have. In this tutorial, we're going to be looking at how to solve inequalities using sign charts. Particularly, we're going to be looking at quadratic inequalities, meaning that equalities that has the power of 2. So we're going to be looking at some examples to explain inequalities using sign charts. So you have an example here that will find the range of values of x for which the first one, x squared minus 7x plus 12 is greater than 0. So we can see from this equation that it does not contain the equality symbol. So it looks exactly like a quadratic equation, but in this case we have a greater than sign. So you should know that in quadratic inequality, we're actually dealing with symbols that are not equal to. So it can be greater than, it can be a less than, it can be a greater than or equal to, or less than or equal to. So whenever you see any of these symbols attached to a quadratic equation, so we simply refer to those as a quadratic inequality. So this will be our first example. Also, we are going to be solving for x squared minus 2x less than or equal to 16 plus 4x. As you can see here, we have less than or equal to. And lastly, we are going to be looking at another example, which is x divided by x plus 2 greater than 3 all over x minus 2. So using these three examples, we are going to be illustrating how we can solve for quadratic inequality using sign charts. So let's start with the first question, which is x squared minus 7x plus 12. So whenever you have a question like this, the best way to firstly approach this is as if you are treating a normal quadratic equation. So first, we have to find the zeros of the equation. So, and how do we find the zeros? We simply equate our equation to be 0. So here we are going to have x squared minus 7x plus 12 equal to 0. And you see any of the quadratic equation formula that you know, or any technique, you can solve for this. So here I'm going to use factorization method to solve this. So I have x squared, so minus 3x minus 4x plus 12 equal to 0. And I can factorize this. So here I'm going to have x in the bracket x minus 3, and I'm going to have negative 4. Yeah, the same thing, x minus 3 equal to 0. So here I have my two factors to be x minus 3 and x minus 4 equal to 0. So to find the zeros of this quadratic equation, I simply find the solution to each of these factors. So I'm going to have x minus 3 equal to 0, or x minus 4 equal to 0. And from here I have that x equal to 3 or x equal to 4. So the first step is to find the zeros of the equation. So after finding the zeros, you simply study the zeros and look at which one is the smallest, which one is the smaller, and also which one is the greater. So here you have that 3 is the smaller number, which is the smaller root, and 4 is the bigger root. Then we use a sign chart. So this is the main point of this class, using a sign chart to solve for quadratic inequality. So after getting the zeros, then we draw out a sign chart. So how do we draw the sign chart? It goes like this. So the first thing you bring in is to bring into the two factors of the equation. So we have our factors here to be x minus 4 and x minus 3. And lastly, I put the product. I'm trying to roll a line here. So after drawing out the two factors, so the next thing is to look at the smaller of the roots and put in x less than the smaller root, which is 3. So it's going to follow this same pattern in all occasions. And for the second column, we're going to have the smaller number, which is 3, less than x less than the bigger number, which is 4. So it's going to follow the same pattern in all occasions. And lastly, we are going to have x greater than the greater number, which is 4. So study this very well. We are going to have x less than the smaller number less than x less than 4, and the third column will be x greater than the bigger number. So even if you have more than 2 roots, it's going to follow the same pattern. So just to draw this out, it's going to be x less than the smaller number. So the small number less than x less than the big number, and lastly we are going to have x greater than the big number. So take note of this, is going to follow this same pattern in all occasions. So after drawing out this particular range, so now we now pick a particular number that satisfies each of this range. So if you say x less than 3, we can pick any number that satisfies this. So, and most of the time, try to pick a number that is very easy for you to work with. So here I'm going to pick 1. I always stay in the range of 1, 2, or 3. And here I have 3 less than x less than 4. So the best number I can choose here is simply 3.5. And here x greater than 4. So I can pick 5 here. So after picking 1, 3.5, and 5, so I'll now try to substitute all this number into my factors. So if I substitute 1 into x minus 4, I'm going to have 1 minus 4, and this is going to be negative 3. So I'm getting a negative answer. So you simply put the negative in. So remove the number and just simply put whether the answer is negative or positive. Again, I'm going to put negative 1 into the second factor, which is, I'm going to put 1 into the second factor, which is 1 minus 3. So 1 minus 3 is going to be negative 2. So I'm getting a negative answer also, so I put a negative symbol here. Then I find the product of the two factors and also the product of the two signs. So these are negative multiplied by negative, I'm going to have positive here. So the same step will be repeated through the second column and also the third column. So in the second column, if I substitute 3.5 minus 4, I'm going to have a negative answer also. 3.5 minus 3 is going to be a positive number. And if you find the product of negative and positive, this is going to be negative. So lastly, I'm going to put in 5 minus 4, and this is going to be a positive answer. 5 minus 3 is going to be a positive 2. And multiplying this, I have positive. So with this, I'm done drawing out the sign chart. So you now go back to the quadratic inequality that we are given and study the sign that is associated with it. In this case, we have the sign greater than associated with our equation. So whenever you are looking at greater than, let me draw this here. So whenever you are looking at greater than, so always look forward to positive sign, and when you are considering less than, always look forward to negative sign. So this can also be greater than or equal to, or less than or equal to. So now coming back to our sign chart, we know that the symbol we have on the equation is greater than. Then we pick all the occurrences of positive in the product. So here we have positive, and also here we have positive. And then we look at the range that falls in that column, and that will be the answers. So here we have the x less than 3, and also we have x greater than 4. So the solution to the quadratic inequality is going to be x less than 3 and x or x greater than 4. And this will be the solution to the quadratic inequality using sign chart. So if in case we have less than over here, we simply pick the one with negative, which is 3 less than x less than 4. And then we have the solution to the quadratic inequality, x minus 7x plus 12 is greater than 0. So that's about the first question, which is this. So now moving straight to the second question, which is x squared minus 2x less than or equal to x 16 plus 4x. So the same operations will be performed here. So number 2, we have x squared minus 2x less than or equal to 16 plus 4x. So here the first thing we have to do is to find the zeros of the equation. So how do we find the zeros? In this case, we can simply perform some operations on the quadratic inequality. So we are going to have x squared minus 2x less than or equal to 16 plus 4x. So there's a pattern of performing operations with inequality. So we don't simply collect like times or just move values or variables around. So we try to perform the same operation both at the right hand side and also the left hand side. So now to eliminate this, so that we can have 0 at the right hand side, we can subtract 16 plus 4x from both sides. So if you subtract 16 plus 4x from both sides, so we are going to have the right hand side to be equal to 0. So we are going to have x squared minus 2x minus 16 plus 4x less than or equal to 16 plus 4x minus 16 plus 4x. So here we have this to cancel out to be 0. And here we are going to have x squared minus 2x minus 16 minus 4x less than or equal to 0. And quickly collecting the like terms, this is going to be x squared minus 6x minus 16 equal to 0. So now to find this to find the zeros, we can just solve for this quadratic expression. So here we can find the factors, and I'm going to have x squared plus 2x minus 8x minus 16 equal to 0. So factorizing this, we have x in bracket x plus 2 minus 8x plus 2, and I have the factors x minus 8 and x plus 2. So to find the solution to this is going to be x equal to negative 2 or x equal to 8. So we have x equal to negative 2 or x equal to 8. So the next thing to do is to draw the sign chart. So again, following the same pattern, so we have this, and we have the factors here. So putting down the first factor that we have here, so this is going to be x plus 2, x minus 8, and this is the product. Now also drawing out the ranges, so we pick the smaller number, the bigger number, and we write out the expression using the less than. So we are going to have the s less than the smaller number, which is x less than negative 2, negative 2 less than x less than 8, and x greater than 8. So as I mentioned, it's going to be following the same pattern in all occasions. So again, we try to pick a number that satisfies any of this, each of this range. So x less than negative 2, we can have negative 3 satisfies this range. Here we can have 1, and then we can have 9. So don't forget, remember to pick the number that is most convenient to work with. So if I substitute negative 3 into the first factor, I'm going to have negative 3 plus 2, and the answer is going to be negative 1. So I have a negative answer. So again, substitute negative 3 to x minus 8, and this is going to be a negative answer also. And finally, the product of negative and negative, I have positive here. So again, substituting 1 plus 2 is positive 3. So 1 minus 8 is negative, so I have negative here, and positive and negative is going to give me negative. And lastly, substituting 9, I have 9 plus 2 to be 11, so this is going to be a positive answer. 9 minus 8 is positive 1. And finding the product of positive and positive, this gives us positive. So again, going back to the expression that we are given, so here we have a less than or equal to symbol. So therefore, we are watching out for negative. Whenever you have less than or less than or equal to, we watch out for negative, which we have here. So the solution to the quadratic inequality is simply the range that falls. So the third question, we have to find the range of value for which x divided by x plus 2 is greater than 3 all over x minus 2. So here, one of the things we have to do is to make sure that we bring this to a quadratic expression. And as you can see, just like the last question, both the left hand side and right hand side, none of the side is equal to 0. So we have to try to turn the right hand side to be 0. So how do we do this? So we can multiply the both sides by x plus 2 squared and x minus 2 squared. So before I proceed, I want to point out something here. So in case if you have a normal equation that looks like this, for example, if you have x divided by x plus 2 equal to 3 over x minus 2. So what we can simply do here is to cross multiply, and by the time we cross multiply, we're able to find the solution to x. But in this case, as I mentioned in the last tutorial, for quadratic, whatever we are working with quadratic inequality, or whenever we are working with inequality generally, to reduce a term or to collect like times, we simply try to add a particular value or a particular variable to the both side, both the left hand side and also the right hand side. We can use this to eliminate, we can also use it to divide, and we can use it to multiply the whole equation. So to cut out x plus 2 and x minus 2, to turn this to a linear equation, we can both multiply the sides by x plus 2 square and x minus 2 square. And doing that, we are going to have x, let me clean this and change to a more vibrant color. Okay. So we are going to have x divided by x plus 2 multiplied by x plus 2 squared x minus 2 squared is greater than 3 over x minus 2 multiplied by x plus 2 squared x minus 2 squared. So you are going to have x plus 2 to cancel out one of the x plus 2's here, and also x minus 2 to cancel out one of the x minus 2's here. So this leaves us with x to bracket x plus 2 and x minus 2 squared greater than 3 into bracket x plus 2 squared x minus 2. So now our purpose is to make the right hand side to be equal to 0. So what we can do now is to subtract 3 x plus 2 squared x minus 2 from both sides. So this is going to leave us with x plus 2. I won't be writing this in full. X minus 2 squared minus 3 x plus 2 squared x minus 2, and this will be greater than 0. So we have removed the value from the right hand side, leaving 0 at the right hand side. So now looking at this, we shouldn't try to find or try to open this bracket. It's going to make the work a long one. So what you can do is to firstly factorize this expression at the left hand side. So what is common in this and also this? So we're going to have x plus 2 and also x minus 2 is common in both sides. So factorizing this, we are going to have x minus 2 left. Since after factorization, we pick one of this and also one of this. So we're going to have this left and also one of this left. So if you try to open this bracket, the square bracket, using the expression we have here, so we're going to have the same thing that we have over here. So this is going to be minus 3. So after removing x plus 2 and x minus 2, we are going to have 1x plus 2 left. And we have already removed the x minus 2, which is what we have here. So trying to open this bracket now, we still have what we have at this side. So having this, we can proceed. So this is going to be x plus 2, x minus 2, angle bracket. So opening all these brackets, we have this to be s squared minus 2x minus 3x minus 6 greater than 0. So here we have x plus 2, x minus 2. So here collecting like times, this is going to be x squared minus 5x minus 6 greater than 0. And now we can solve the expression inside the angle bracket using a quadratic factorization. So this is going to be x plus 2, x minus 2. So factorizing this, we are going to have x squared minus x minus 6x minus 6. And this is going to be leave me with x plus 2, x minus 2, x to bracket x plus 1 minus 6x plus 1. And I have this to be x plus 2, x minus 2, into brackets x minus 6, x plus 1, which are the factors of the expression. It's greater than 0. So writing these 4 factors out in full, so I'm going to have this to be x plus 2, x minus 2, x minus 6, x plus 1 greater than 0. And here we have all the 4 factors of the quadratic expression. So the next thing we have to do is to find the zeros. And how do we find the zero? Simply we equate all the factors to be equal to 0. So we're going to have x to be equal to, let me change this. So x is so x equal to negative 2, or x equal to 2, or x equal to 6, or x equal to negative 1. So and these are the zeros of the quadratic inequality. So the next thing is to draw a sign chart to illustrate this. But in this case, we are looking at 4 different factors. So there's going to be a little change in the sign chart. So again, is it going to follow the same pattern? Drawing this and making a straight line. So you can write out the factors of the expression. So the first one we have x plus 2. We also have x minus 2. So we have x minus 6. And lastly, we have x plus 1. And then we can find the products. So now drawing out our range. So it's still going to follow the same pattern as I mentioned. So the first one we are going to have is x less than the smallest, which is x less than negative 2. So now negative 2 less than x less than the following number after negative 2, according to ascending order, here which is going to be negative 1. So here we are going to have negative 2 less than x less than negative 1. So we're still going to have another column, so which is going to be negative 1 less than x less than the next, which is 2. Again, this is going to be 2 less than x less than 6. And lastly, we are going to have x greater than 6. So now we can try to find a value that satisfies each of this range and substitute it in our factor. So here we can pick negative 3. Here we can pick negative 1.5. We can pick 1 here. Here we can pick 3. And we can pick 7 here. So now trying to substitute negative 3 minus negative 3 plus 2 to the first factor is going to leave me with a negative answer. So negative 3 minus negative 2, again is going to be negative. Negative 3 minus negative 6, this is going to be negative 9. And negative 3 minus negative 3 plus 1 is going to be negative 2. Again, we have negative. So let me multiply this. So negative multiplied by negative, this is going to be positive. Positive multiplied by negative, this is going to be negative. Negative multiplied by negative, this is going to be positive. And then I have positive to be the product. So again, if I substitute negative 1.5 to all the factors, here I'm going to have positive. This is going to be negative, and find the product, I have negative. If I substitute 1, this is going to be positive, negative, and positive, and I have positive as the product. If I substitute this range, which is x equal to 3, I'm going to have positive, negative, and positive, and the final answer of negative. Again, if I substitute x greater than 6, it's going to be positive, 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 and I have my final result to be positive. So again, you scroll back to the equation that was given, and then you have the greater than symbol. Therefore, we pick all the occurrences of positive in our sign chart. So we pick this, and lastly this. So the solution to the expression is simply s less than -2, -1 less than x less than 2, and s greater than 6. So this is how we can solve for quadratic inequality. We look at the first example, the second example, and the third example, and look at a more complicated example during the third example. So if there's any question regarding how to solve for quadratic inequality, feel free to post the question using the comment section below, and I will reply as soon as possible. If you find this tutorial useful at all, don't forget to like it, give it a thumbs up, and also subscribe. Thank you, and I'm going to see you in the next tutorial where we are going to be proving a particular theorem in mathematics.